Okay, so that's just kind of the general setup in the system. We talk a lot about managing performance, so how does that manifest itself out to the end users? Because it's kind of a different paradigm. And we just walked through this slide. You guys all know this, that today you configure SAN performance, you don't really manage it. And all we mean by that is, depending on the number of disk drives, the controller, the number of ports, that basically gives you one big pool of performance resources that all of the applications that are sharing that tap into. So when one application spikes, the other applications are impacted. This is how every shared storage system works today. What we're trying to do is say, well, if you look at capacity, you can carve up capacity in the system and apply it directly to whatever management paradigm you're dealing with, whether it's a volume or a file or whatever. So we want to do that same thing with performance. So we'll characterize our system and say that you have X amount of performance. And just even taking that step is a leap for most storage systems because they're really hard to characterize. What we're doing is we're providing a logical pool of performance that we know is not quite all, but close to all of the performance resources. And then we start allowing customers to carve up that pool of resource on a volume by volume basis. And how we're doing this is we're setting guaranteed minimums for these applications. So that way the administrator always knows that no matter what's happening in the SAN, if the application workload is driving the system hard enough, you will never get below this level of performance. Now, if there's performance headroom and some of the applications aren't consuming all of the performance that's been provisioned to them, we allow those applications to spike and take up what's ever left in the system. And then as soon as the contention starts happening, everything defaults back down to these guaranteed minimums. So this way, you can set these quality of service policies, manage it over time. You can look and say, hey, I haven't needed 10,000 IOPS. I want to take 5,000 back and provision it out. That allows a much more efficient way to handle the performance resource in the SAN, as opposed to, I hit the performance cliff, I need to go buy more resources, whatever they may be. So we're just trying to provide that new management paradigm. So guaranteed minimums are essentially exactly what we're describing. You set 10,000, 20,000, 5,000 IOPS. You also categorize or prioritize the importance of these workloads with this concept of service levels that we'll get into in a little bit. But that tells us how important it is. And to us, how our system treats a service level is a mission critical service level will be the most consistently delivered service level in the system.
Do you have the ability to set a ceiling?
Not today. Not today. So quality of service in action. So what we did is we had an analyst firm come in and just do a tech validation of quality of service. So what this test shows, what's that?
Nothing.
Okay. So what this shows is, we're ramping up our total system performance on the top graph. We've got a mission critical workload, Exchange, a business critical workload, SQL Server, and a non-critical workload, a backup job. And what we do is we've set Exchange at a certain level, a certain threshold, or guaranteed minimum. And then what we do is we kick off a pretty heavy-duty random I/O workload, represented by SQL. And then we kick off a very heavy throughput workload from the backup job from Commvault. And what you see is that nothing happens to the Exchange workload. That's what our quality of service engine is doing. It's isolating these workloads from one another and ensuring that no matter what else is happening on a SAN, you're going to maintain consistent performance on that mission-critical application, in this case, Exchange. So that's kind of the quality of service and how we provision the performance up front and maintain the performance in steady state. Service levels is another paradigm that we've implemented, as I mentioned before, that's about prioritizing the workload for us. So in any SAN, because they're all sharing the same performance pool, you'll run into these issues. Component failures, you'll do firmware upgrades, you'll be doing a rebuild. What's going to happen is everything's impacted equally. So everything goes down the same amount. And of course, some of these are more important than others, but you have no control over which ones should take the performance that's left. What we want to do is When you create a volume on our system, you attach a quality of service policy that sets a target, and then you tell us how important meeting that target is. Is it mission critical, business critical, or non-critical? And then when these things happen, like a component failure, system upgrade, or a rebuild process, we impact all the non-critical workloads first, down to some minimum level, so we remain connected, but we slow everything down. Then we try to mitigate the impact to the business critical stuff as much as we can, but we always will guarantee that the mission critical will maintain their quality of service targets. The reason that we can do that is because we only allow end users to provision up to half of the system for mission critical. You can't provision more than half, because if we would lose a controller, we would lose half. And then in that scenario, if we were fully utilizing the system, all the non-critical, business critical stuff would go down to a minimum level to remain connected. The mission critical stuff would remain, at the level that you prescribe.
So when you say half, you're saying that the system has some declared capacity to deliver IOPS, and I can assign floors of up to half of that?
Correct.
Okay.
Correct. This is service levels in action. So, what does that mean? What does that look like in steady state operation? Again, we've got the total system IOPS on the top graph, and then we've got our 3 workloads: mission critical, business critical, non-critical. You see Exchange clipping away, and then what we do is we injected a controller failure, or we went and just unplugged one of the controllers. So we're active, so both controllers are contributing to performance. When you lose half of it, you lose half the system performance. What you see is that the system drops by 36%. The mission critical volumes were not impacted. You see a little blip, a microsecond blip, but then we immediately catch back up to where we need to go. That shows the real-time nature of what we're doing, because we're managing and looking at all of the blocks and inspecting them as they're coming in and going out. And then you see the impact on non-critical volumes versus business critical, where non-critical was impacted more because you've told us that they're less important. So again, service levels is just a way for us to give the customers to prioritize and tell us which workloads are more important to you. We're going to maintain a more consistent level for those applications. Then we've got some new stuff that we just announced yesterday. I'm not going to spend a ton of time here. I just want to hit a couple points. Because we have this ability to manage performance, we really wanted to provide the intelligence to go along with that. So we're building out our monitoring capabilities. And we've got a stats database that basically records all the I/O since time began from a system perspective. Granular reports, but what's really interesting is we've taken some of Kelly's, he's got a whole testing suite that we do on all solid state components that come in, so we know exactly how to characterize what they're doing. Some of the best tools that he uses to look at that, we've been integrating into the performance monitor in the form of histograms, so we can break down by block size and see how many of what block size you're getting and what the latency is, and break down on those different block sizes, which I know you use a lot, and it really helps the troubleshooting process to understand what's going on from a system perspective.
So how interested is the mid-market in chargeback? I mean, that's the obvious next step, but only if they're interested. So I'm curious what kind of feedback.
It's why we don't have chargeback today. We don't see a ton of interest in chargeback. Now, as we grow and as we see some of our regional VARs becoming service providers, that's when we're seeing that conversation happen. We will go there. It's just a matter of when do we want to attack that particular problem. But right now, in the current mid-market, it's really about, I just need consistency, and I need to know what I'm going to get out of that thing.
Having spent a long time consulting in the mid-market, they don't have the division of business units to bill back.
They don't do
Right.
chargeback.
They don't have, chargeback makes sense when you have multiple independent P&L entities to charge to. When the whole company has one P&L,
Right.
there's, billing back departments just doesn't.
Yeah, cloud service providers are certainly very interested in chargebacks, but your typical mid-range IT shop isn't, but they are very interested in delivering quality service to all their end users.
Right.
kind of two things that are a more advanced customer that is actually already built into the system. And you guys were asking about one of them, the maximum ceilings, right? The system's built in to allow that. It's already coded up, it's there. We just set the max all the way up. So we don't
Just-
allow
just haven't
customers to use
exposed it.
We haven't exposed it. The chargeback mechanisms, the system has the ability to do all of that and track it all and tell you what's happening. What we have exposed was in the previous slides there, where you can see we can allow them to help troubleshoot it because they can look at the performance and compare what things are doing. So giving them the tool to say, I'm broken, why am I broken? That's valuable even in that market. They're not going to charge back, but they need to know what to go fix and what's broken. So we've given them the first step, which is the visibility into it. And if we want to, we can add that second step of, okay, now do you want to start charging? Go ahead.
The data store of virtual machine mapping that you have up there, and
Yeah.
is that to combat the storage DRS remappings within?
No, it's simpler than that. It's literally it's a vCenter plugin integration that just shows you these VMs are on this data store, which relates to this volume. So we just show that.
Because I know that's a problem with some monitoring programs when storage DRS kicks in and moves machines around. The mappings get messed up, and I'm just wondering if that addresses that.
It's more to help the port admin keep track of which VMs are assigned to which QoS, because
That's-
QoS is on a
Well, it's under the
volume by volume.
monitoring, that's why.
Yeah.
No, that's Howard's exactly right. We're just trying to provide that view.
I have to admit, I got briefed last week.
So along those lines, we do have a vCenter plugin. We recognize that managing volumes, that's interesting. A lot of people manage their virtual infrastructure, though. We want to move up in that food chain. So what we're doing here with our vCenter plugin is essentially we're allowing our quality of service policies to be applied directly on a VMware data store, so that these VMs are related to this data store, and I've got this data store in a mission critical, high performance policy. That gives you that insight. The other thing that we do is, when you provision a data store, it's all automated, wired up on the back end on our SAN. So you create a VMware data store, makes all the connections, creates the iSCSI LUN provisions on our system, acknowledges back that everything's done and working, and then you apply a performance policy on it. Well, let's say you've got VMs that need more horsepower. You just go in and you move it from policy 4 to policy 3. The way we've got it set up is it's 5 policies, 1 through 5. They all have latency, bandwidth, IOPS targets, but we've put them in templates. So from an end user perspective, all they really need to know is, do I need more, or can I get away with less? And that's how they're setting this. They can do it from vCenter in real time, with no impact, no downtime. There's no restriping of data because this is in the data path. That's how we're managing all this, inside the system.
So are there only 5?
Well, there's more than 5. We're exposing 5 today. So maybe you
sure.
can comment on that,
Yeah,
Kelly.
the system today is coded with 10. There's reasons for us to have some internal ones, and so we've exposed 5 out to the customers. And then for internal movement or internal adjustments that we need to do, we'll use one of those. Our lowest tier is generally, or our lowest policy is generally the one we use.
So-
It's not, we're not limited to that. It was just a choice we did now to try to keep things simple, right? Keep it simple, get it out there, get customers using it, get them familiar with it. Today, we don't let them set a ceiling, we don't let them change the floors. All capable of being done. We
You
just
don't let
kept
them
it
change
simple.
the floors.
Today, we don't let them do that.
Okay.
Oh,
It's all capable of that.
Mhm.
We have just chosen not to expose that to them. They can move things between them.
Right. So they can change the floors by putting it in a different policy. We don't allow the changing of the policy itself yet.
The long-term vision is our API will allow you to select latency levels, throughput levels, and IOP levels, and dynamically adjust those parameters on a given data set. And so, as we move into larger environments, more sophisticated customers that want to leverage that API real time to deliver a service level for whatever reason, and maybe even, we're also going to have a view towards scheduling this stuff as well. So there's a scheduler in vCenter. We're going to have a scheduler on our system. So if you need a QoS policy, for example, VEI boots from 8 to 9 in the morning, your scheduler schedules a higher QoS policy during 8 to 9 and then drops it down after that. or, you know, Friday afternoons, all your billing queries run, you can schedule that event in the scheduler and change QoS policy.
Hey. This just kind of highlights what it looks like, and we've talked a lot about this. So up on top, this is just a dialog box in vCenter. So up on top is all the standard stuff that you're going to do when you provision a data store. How big is it? You know, what VMFS is on it? What's the size? The bottom half of the dialog box, though, shows the policy and exposes the targets for that particular policy. So what you see is policy 2 is the second fastest. It's got a bandwidth, IOPS, latency target, along with a service level, which prioritizes the workload inside our system. And that's what makes us really different. We're basically defining the characteristics of the data store performance directly in vCenter. If you need it changed, if you want more horsepower, you crank it up to a lower policy. If you want less, you crank it down. You can do that live, real time.